All right, so we already had talked about group by a bit. Let's just revisit it real quick. As we mentioned last time we met, it's a mechanism that allows us to grab records in the same table that might somehow be related to one another, either because we're all in the same section, we're all in the same course, we all belong to the same university, and there's a field that captures this idea, right? That we all belong to a certain group, or we have the same last name, or we have whatever, right? We're all in the same zip code. We're all in, and there's all different ways of collecting us or grouping us by any one of those fields. Okay, and then considering that group as a single entity. Right, and so, for instance, if we all are in the same zip code, then you can answer questions about everybody who lives in a particular geographic location, right? If we all work in the same department, then you can ask aggregate questions about everybody who's in the same department. Yes, so that's what group allows us to do. Group them in any one of those fields that are or might be the same across multiple records. But that introduces a couple of challenges. Is that what happens to the other fields that are not part of the group, right? Well, the only thing that we could possibly do with those other fields is to answer questions about their aggregates. Right? So, for instance, if we ask, I want to look at this zip code, and what could you ask about all the other things? Because we have each one of it has very specific pieces of information. I have my salary, and you have your salary. Right, and we happen to live in the same zip code. So what can we do about the individual salaries? Well, we can't answer anything about any individual salary. We can only possibly answer questions about the aggregates of those salaries, right, in the group. Make sense? Right. So any question about any specific salary inside of a group is meaningless. Right. So group allows you to group by and then by a particular field, and then answer questions about the aggregates of all the other fields that are not grouped by. Okay, and that introduces some limitations of what you can do with group by. So we looked at the syntax, select column, and so the column that you're grouping by, and the only thing that could possibly be on the select statement is the column you're grouping by. You have a value. You know what that value is, right? The zip code or the department or whatever. You have that value, so you can select it. You can retrieve it as an output. But all the other fields, they're not available to us, right? They're only available to us as an aggregate, right? So we can only possibly have access to the other columns that are not part of the group to apply them some aggregate function. Right, so it would be invalid to ask for other fields here, other than the field that you're grouping by, and it would be invalid, right, because any one of those values is gone, and that has a very, very peculiar consequences, right? So of some of the limitations of what group by introduces. So here's a couple examples on grouping by. Say the customer, and so there's three distinct groups, right? Alice, these three records are part of the Alice group. These two records are part of the Charlie group, and Bob is all by himself, right? Doesn't have anybody else that is also Bob. So he's all his own group. Now a couple of things make sense to group, like over here, because we know that these values are repeating. Okay, maybe a last name, maybe a zip code, things like that. Some values make no sense to group by, right? Because these are scalar values, right? They have some continuous value, right? And they're not necessarily meaning anything for them to be repeating over and over. Maybe a range, might make sense, but not individual values such as this. Grouping by dates, that also makes no sense, right? Because again, this is a scalar value, has a continuous value. Same thing, grouping by ID, that makes no sense either, right? That's monotonically incrementing. So only makes sense for some fields, right? That have some repeating value. that you might want to consider them as being somehow related to one another. So here we're grouping by the customer. Since the value of the customer survives, because those 3 records made it up into just this one record, those 2 made it up into Charlie, and this 1 made it into Bob, we have those values. We can retrieve them. But it would make no sense to ask for any of the other fields, right? For instance, the order themselves are gone. I don't have them. I could ask I could ask aggregate questions about those prices, but the individual prices are gone. Right? I don't have them here. So it would make no sense for me to say select also comma order price, right? Because what would I put in there? Would I put the 3 values that are somehow grouped together? It makes no sense, right? I can only aggregate them. Also, the aggregate function that I use also depends on what makes sense, right? Here we're adding up all the prices. Maybe what would make sense also would be perhaps asking the average price, perhaps, yes? Or the maximum or the minimum. But some of the other fields might make no sense to add them up or average them. For instance, if you were grouping the IDs, it would make no sense to do the average ID or the maximum ID. It makes no sense, right? So it only depends on what is it that makes sense to you. If you omit the group by and you have an aggregate function, this interprets the question as being the entire table being an entire group, right? So for instance, each individual element is it's its own group, so they're not grouped. So Alice and Alice are not grouped together. The entire table becomes one single group, and you're applying the aggregation on all the individual fields of that particular field that you're aggregating, right? And then all the values are the same all throughout the records, the resulting record. If you are grouping by multiple fields, then the ones that end up as being part of the same fields of the same group are the ones that have the same value for both of them, right? So maybe last name and middle initial, or here the order date and the customer, right? If they're the same, right, in 2 separate records, then they would belong to the same group, right? Again, the same rules apply to all the other non-grouping fields. Here's another example. We are asking on the student table, we are asking the grouping by major. So we're taking everybody who is in the chemical department, everybody who's in the drama department, in the math department, so on and so forth. We are asking, what is who's the youngest, who's the oldest, on who's ready to graduate or not, who has the minimum and max. So we have a range of folks that are passing by the department. Okay. Also here, notice that we're using as, so that we are giving an actual name to the aggregate. Otherwise, the default would be the database would jumble up the name of the aggregate function, jumble it up with the name of the field, the original field, right? So it might choose a label for that column that makes absolutely no sense. So it's good practice to always use as and name it to something meaningful. Some limitations of group by are based on when does the grouping occur, right? When does the grouping occur, right? Notice that first you have to be able to run the filter, right, on the where clause, right? You might have millions of records, of which you're only probably interested in only a very small subset, perhaps only 100 records, yes, that might meet a particular criteria in the where clause, correct? Once you've identified that these are the 100 records that you care about, now you can do the grouping and check to see, for a particular field, where are the repetitions, so I can group them. Make sense? So the grouping happens after the where, because the where has to run first, so that you filter out from 1 million records, you filter it down to only a small subset. Yes? Once you have the small subset, now we can go and see, okay, which values repeat and how can we group them. Make sense? So that's a very fundamental thing, because that plays into some of the limitations of group by, right? The things that you cannot do with group by, right? Things that would make a group by illegal. So yeah, so it happens after the where. First, the where filters out all the records that don't meet your criteria, and you're only giving a subset of the records. So first, you identify which are the records. Now that we have the records, okay, the select clause, what does the select clause do? Right, the select clause chooses which are the fields that end up being displayed. Right, it's a projection. Right, saying, okay, well, I have all the columns. I only want a subset of the columns. Just like the where clause chooses a subset of the records, right? The select clause chooses a subset of the fields. Make sense? Right? Once you've aggregated, once you have run the order by, right, and you've grouped by all the records that go into a particular group. Now the where clause the select clause can choose to say, well, what do I do with the 10 records that were collapsed into this one single row? Right? I've identified the 10 records that go together. What do you want to do with all of these records? Do you want to sum them up, or you want to average them? What do you want to do with them? Okay? So the aggregation has to happen after, right? After the where clause, but it has to happen before the select clause. Right? It has to happen before the select clause. Meaning you don't have access to the individual values, you only have access to the aggregates of those fields. Because of these two rules, right, that of when the order by occurs, there's certain things that you just cannot do with a group by. So let's look at some of the limitations. Let's use the same exact database that we've been using so far. And let's take a look at a toy query we explored earlier using relational algebra. Right? Relational algebra, we toyed around with the idea of being able to calculate how many A's a particular section got, right? And then finding out what is the maximum number of A's. And the final question was, well, which one was the section that gave out the highest number of A's? Yes? So first let's look at counting the number of A's, total number of A's. That's easy, right? We just group by section, and we count the enrollment IDs. And that tells us how many A's each section gave. Right? We still don't know who has the maximum number of A's. We just know how many A's everybody gave. Yes? Right? If we then use this result to feed it into the next query, we can then calculate which one is the maximum number of A's. Right? So maximum number of A's, and this tells me well, the number maximum is 4. Out of the 3 sections, the maximum number of A's was 4. But notice that one thing that we cannot ask here is, give me the number of A's, comma, the section. Right? We can't do that, right? Because the sections are gone. Right? You group them. They were grouped. The entire table was grouped. So the individual values of the records are gone. Right? You only have aggregates of those fields. Right? So it would be illegal to do a comma here and then ask for the section. It would be very convenient though, right? It says, okay, I know what the maximum number of A's is, but I don't know which section got it. It could have been 3 sections got the same exact number of A's. Which one do you want? There's no way of providing it, right? It's gone, right? The where clause already executed. So just to illustrate this problem, let's take a look at an actual example. We have here 3 different sections, section 1, 2, and 3, of which section 1 gave out 2 A's, section 2 gave 3, and section 3 gave 1 A. All right, so we group them by section ID. If we group them by section ID, this is what we get, right? Section 1, 2, and 3 gave out A's 2, 3, and 1. Right? In the second query, we calculate the maximum number of A's, and we came out to say that 3 is the maximum number of A's. But notice there's no way to ask here, hey, by the way, give me also the section. Right? The only way we can find that out is that if we join this one with this other query, right, and say, well, which one is it? 3 matches with 3, and we get section number 2. Yes? But there's no way for the group by to answer this question here unless you do the join. Right? So that's what I wanted to point out, what the limitations of the group by are. For instance, it would have been very convenient if we could have just said, select the maximum number of A's, comma, oh, and the section. Give me the section ID. But that's illegal, right? Because right, the grouping hasn't happened yet, right? I have to wait for the where clause to execute. Or we could have done something like this, where like this, where we ask, I want to filter out the records. I want to only keep the records that have the number of A's being the maximum number of A's. But I can't do the aggregate yet because I haven't yet identified who the records are. Right? The where clause hasn't. I need to wait for the where clause to execute, right, to identify the sub records and then do the grouping. Right? I can't do an aggregate because the grouping hasn't happened yet. Right? The where clause has to happen first, right, to identify which records, and then I do the grouping. Right? I can't have the aggregate before I even know what the groups are. Make sense? Right, so this is a conundrum. I can't do either. I can't do my I can't use my aggregates here in the where clause, right? And all the fields that I need are gone by the time I get to the select statement, right? So this is one of the fundamental limitations of group by. The only thing to get around this is to join the two queries together where the maximum number of A's matches the number of A's, and then this matches a particular section that we can retrieve. So joining the two subqueries, right? But there's hope. There's hope. There is an additional function, an additional operation that can behave the way we want it, right? Just like we want it right here, right? Where we can have aggregates in the where clause, right? We would love to have something like this, but not the group by. The group by doesn't have that. Right? Instead, we have what is called the having clause. The having clause. The having clause allows us to do just that. Be able to do the group by. Once we have aggregated, right, then we can ask questions in the where clause, right, about those aggregates having a particular value or a particular predicate. Right? It allows you to apply the aggregate function in the where clause, right, to a particular column, and then making it equal to some value so that it's greater than or equal to or whatnot. All right, so let's look at a couple examples. Here's an orders table where we have Boone, Nielsen, and Jensen, and we're going to group by the customer. That means we're going to create three groups: Boone, Jensen, and Nielsen, but we're going to filter. We're going to filter by this aggregate, right? So that once they're aggregated in the order price, once they're added up, I don't want the ones that are greater than 2,000. I only want the ones that are lower than 2,000, right? Which is exactly what we want, right? We want to have the where clause allow us to filter out certain records based on the aggregate functions, right? Here's another one. Where we apply the summation, the aggregate function, and we filter out only those orders that are greater than 1,500. So the group by once the group by runs, and once it has identified all the subsets, all the groups, right? We can then apply these operators to filter even further and remove any records that don't meet this particular criteria, which is pretty cool.